Alright, so now that we have gone through the concepts of chapter 7, it's time for us to do some practice. So from the lesson part, we've learned about the central limit theorem and then how a sample mean acts as a variable between samples for a given sample size. And then it's not just any distribution, it's approaching the normal distribution. That's what the central limit theorem says. So let me first change the color to black. So for large sample size, x bar is normal with the population mean mu and standard error sigma over square root of n. Sigma is the population standard deviation, that divided by the square root of the sample size, you get the standard error. So standard error is simply the standard deviation of this variable. So standard error is simply this standard deviation of the variable sample mean. Okay, so just to distinguish it from the standard deviation, we use the term standard error, but it's the same idea. When you have x bar, you have this is mu, and then the spread is sigma over square root of n. Okay, so when you know this picture, we can calculate any probability, any area between two values, right? Okay, so I'm going to use our worksheet on D12. So go to chapter 7 worksheet and we will start from number 4 because I ask you to do up until number 3. Okay, so let me see, I think I can get it up here. Okay, so get the PDF on whiteboard. See if it's going to. Alright, let's only get this one for now. Okay, so let me see. There you go. Okay, so number 4. Oh, can I write down it? Yes, I can. Okay, number 4. So what's the difference between sample mean? Okay, what's the difference between sample mean and the population mean? So in my lesson we talked about this. Remember, you have the actual number, you have the exact number, the actual value and the calculated value. The difference between the two is called the sampling error, the error due to sampling. Okay, that's number 4. And then I'm going to get the next page. So, okay, let's see if I can make it a little bigger. Right. Okay. Well, even if you guys can't see it from here, you know where to find it, right? Okay. I don't know why it's going back. Okay. I'm getting messages. Okay. Right. So number 5, an experiment involves randomly selecting a sample. Okay. Sample of 256. This is our n. Middle managers for study. One item of interest is their mean annual income, x bar, or average. Okay, the sample mean is computed to be this much and the standard deviation is that much. So we don't have, so in this is very important. So we actually don't have the population mean and the standard deviation, mu and sigma, right? But what you have to do is you have to assume, okay, this is mu and this is sigma, okay? And the given mean and the standard deviation, those two numbers, you have to assume, okay, this has to be the population mean, this has to be the population standard deviation. And what is the standard error? Okay, this is a very simple one. So we're not going to calculate any probabilities or anything. Okay, let me try. Okay, so we're just going to calculate an intermediate step. So standard error equals to sigma over square root of n. So sigma is 20, 50 divided by square root of 256. Right, so you can use your calculator or you can use Excel. So if you use Excel, you have to do equals. Why don't I get the, there you go. So equals, okay, numbers 20, 50 divided by SQRT, that's the function. SQRT of 256. Okay, there you go. 128, 13. Oh, come on. There you go. So this is the answer. So it's not a probability, it's just asking for the standard error. And same goes here. A group of statistics students decided to conduct a survey at their university to find the average amount of time students spend studying per week. Based on a simple random sample, they surveyed 144, that's your sample size. Statistics showed that this student studied an average of 20, that's your mu, with a standard deviation of 10, that's your sigma. Okay, what is the standard error of the mean? Sigma over square root of n. What is that? So sigma is 10, n is 144, square root of 144. Okay, go ahead and get the number. And same thing goes here. What is the standard error of the mean? Again, sigma over square root of n. 140 is the standard deviation. Sample size is 100. So 14. Okay. Number 8. As the size of the sample increases, what happens to the shape of the sampling means? So this is exactly a question about the central limit theorem. So we know for large sample size, x bar is normal. So that's what central limit theorem says. For large n, x bar is approximately normal. So you have to pick the one which says that. Okay. And then again, standard error number 9, I'm going to skip that. Number 10, okay, this one is interesting. So this one talks about those two side-by-side comparisons I did. You have a variable and you have another variable which is the mean of it. So in this one, an accounting firm is planning for the next tax preparation season. From last year's returns, the firm collects a systematic random sample of 100 filings, and 100 filings showed an average preparation time of 90 minutes with a standard deviation of 140. Okay, what assumptions do you need to make about the population? Do we need to make any assumptions about the population to make an inference about the average? So this is what it says. Do we need to know anything about X, which is prep time, to make an inference about X bar, average prep time? So according to central limit theorem, the answer is no, you don't. No. Because regardless of, so your preparation time may look like a very weird pattern. We don't know. Prep time. Regardless of this picture, average prep time, X bar, will be normal. That's what the central limit theorem says. So no, the answer is no, you don't have to know anything about the population distribution to talk about the distribution of the sample mean. So it can be anything. The shape of the population distribution does not matter. Okay, right. Then let me get the next page. Because on next page we have the actual probability calculations. Okay. Can I move this? So just bear with me, guys. I'm just learning this tool, how to optimize it. Okay. So here you go. If you can't read it from here, please refer to the actual worksheet on D12. Okay, right, good. So number 11, Prince Edward Island Fisheries and Environment has been feeding a special food to rainbow trout fingerlings in a pond. A sample of 40 and trout revealed that the mean is this much, standard deviation is this much. So like I said, this is your mu, this is your sigma. Okay, now this is a probability question. What is the probability that the mean weight of a sample of 40 trout exceeds 405.5? So now this is interesting. So read again. So what is the probability? It's not asking what is it. It's not asking for weight. It's asking for mean weight. That's where chapter 7 comes into play. So in chapter 6, it was only this part, the highlighted part. It was asking what is the probability that the weight exceeds a number. So the highlighted combination of the three highlighted areas, that is chapter 6. The collection of the red underlined areas, the combination of the three. What is the probability mean weight is more than 405.5? That is chapter 7. Okay, so that's that identification you must do on your own. So this is X bar now we are dealing with. So X bar, here's the mean, 402.7, and then we have a value somewhere here. So I'm just going to go back to the with this information, I'm going back to the sheet so I can draw a larger picture up here. So number 11, so X bar, mean weight is normally distributed with mean 402.7 and standard error mean is 8.8 divided by square root of 40. Okay, and we want to know what's the probability that if you select samples of 40, what's the probability that the average would be more than 405.5? So exceeds, average exceeds means area to the right. So in MegaStat, you're reading the probability upper. Okay, so you go to MegaStat. I'm going to go to MegaStat now. Okay, and you fill it out. Probability, normal distribution, mean, okay, why can't I? Okay, for some reason, okay, there you go. Oh, come on. So for some reason my keypad is not showing up. Okay, so we have to add the mean. Okay, 402.7, and the standard deviation. Okay, bear in mind it's not just 8.8, it's 8.8 divided by square root of SQRT of 40, the sample size. Okay, and then we're reading, we calculate the probability for 405.5. Okay, so I'm just going to keep the decimals to, rounding decimals to 2, not going to change anything else. Click OK. Okay, there you are. So upper reading, this is what we need, right? The probability that the average exceeds 405.5. So it's 0.0222. So this area right here is 0.0222. Okay, so A is the answer. So like you can see, it's not the exact same, right? So you are going to run into that decimal issue again in this chapter as well. So you will have to find the closest possible number. Okay, right, so I'm going to do number 12 and then I'm going to leave the rest for you to try. Suppose a research firm conducted a survey to determine the average amount of money steady smokers spend on cigarettes during a week. A sample of 100 steady smokers, that's your N. Review, that mean is 20, that's your mu. Standard deviation of 5, that's your sigma. What's the probability that for a sample of 100 steady smokers on average spend between 19 and 21? So now we are looking at area in between. So number 12, let's draw the picture. So we are looking at, okay, again I'm going to emphasize the same thing up here. So it's asking what's the probability a steady smoker on average spend between 19. So this is X bar, right? So if it was chapter 6, highlighted ones, probability spend between 19 and 21. But that's not what it says. It says probability average spend on 19 to 21. So that's the key difference. Once again, that's the key difference between chapter 6 to chapter 7. That's your indication, okay? This is a question from chapter 7. I need to get the standard error. not just the given standard deviation. Okay, right, so what's this? Okay, just gonna okay, so let's zoom out. Okay, I don't know what happened here. Try to drag it to the side. Okay, here you go. Then let's go into the picture. Okay, get rid of the highlighter. So mean is 20. Standard error is 5 over square root of 100. Let me double check. 20 and 5 and 100. Yeah, and then we need 19 and 20. So area between 19 and 21. Here you go. Okay, so we need to do 2 readings, right, on Excel. Okay, normal distribution. Need to change the mean to 20, standard deviation to so it's 5 over square root of 100. So that means 5 over 10.5. So I'm just gonna, I did the math, but you can do 5 divided by SQRT of 100 as well. So you need to do 2 readings, one for 21. Click OK. Oops, what was that? Okay, so you run it for, first you run it for 21 and then you run it for 19, and then you can take the 2 lower readings, 0.9772. So for 21 it's 0.9772, and then for 19 it's 0.0228. 0228. So then the area in between, or the probability that the average is between 19 to 21 is the area in between, 9772 minus 0228. So I'm gonna leave you to figure out the difference, and then I'm gonna leave you to figure out the rest of the questions. You have 3 more left, so make sure to do those calculations. And like I said, it's exactly the same pattern. The only difference comes into the standard deviation part when you use MegaStat. Other than that, like in chapter 6, we are still calculating probabilities under normal distribution. So the key is, in terms of an examination, the key is that you need to identify, am I dealing with just the variable? I'm just going to get rid of all these just to make that point clear to you. So is the question asking probability variable, weight is more than something, or is the question asking probability, I shouldn't have done that. Is the question asking probability average of the variable, mean weight is more than something? So based on that, based on this part, am I dealing with x or x bar? Am I dealing with the variable? Am I dealing with the average of the variable? So based on that, you need to choose, okay, if it's just the variable, it's sigma. If it's the average of the variable, sigma over square root of n as the standard deviation. The rest probability calculation is exactly same as what you did in chapter 6. All right, that's it.